Okay, class. So with this video, we're gonna ask the question: is this a function? And what you're gonna be looking at for this lesson is a table of values. So we're gonna look at a table of values, and we're gonna determine whether or not it is a function or not. Now remember that a relationship does not have to be a function. So as a quick review, let's go back up and look at what you have as a definition for function in your notes. So on your vocabulary, you should have this written down, and it says a function is a relationship that assigns exactly one output value to each input value. Now this makes sense. The output value, what you get out of it, what should be unique for what you put into it. So if you type in the number 9 on your calculator, you would expect that you would get a 9 to show up on the screen. So let's look at that. So if I put in 9, well, I punch 9, 9's my input, and I get a 9 up here. That's my output. This is just one example where it wouldn't make sense if I hit the 9 button and I got an 8 symbol, or I got a square root symbol. Should just be one output for every input. So let's look at how that looks with a table. Later I'm going to have you guys come up with examples of these so that you can fully understand this. So I'm going to give you a couple tricks as well. Let's look at this example, and this is a relation and it is also a function. So we have the domain and range. So remember that my domain, well, that's my inputs. It's also my independent variables. And you'll get used to this soon. And my range, well, that's my outputs. And that is my dependent variables. Now if you look at my domain, I have 1, 2, 3, and 4. Now the big thing that I'm looking here is that I have no repeats. And I'm only looking for the repeats on my inputs. On the outputs, well, I can have a repeat here. It doesn't really affect anything. But I can't have a repeat on my domain that corresponds to the same thing in or different numbers on the range. So since I have 1, 5, 2 and 6, 3 and 7, 4 and 8, this satisfies my definition that for every input I can assign a value for an output. Okay, let's do another example of a relation that is a function. So let's call x my independent, my input, my independent variable. Let's call y my dependent. And if I come down here, well, I have 5, 6, 7, and 8. There are no repeats. That's a big tip. And I can see I have a one-to-one correspondence. So 5 is only equal to 7, 6, 10, 7, 13. Okay, so let's look at why this is a relation. So, or why this is a function, sorry. This is a function because each element in the domain, so each element in the domain, is assigned to exactly one element in the range. So each domain, exactly one element in the range. Okay, let's jump down and do a counterexample. So this one is not a function. So let's look at an example of something that is not a function. Well, the first thing, let's go to my independent variable for my domain. Here's my domain. And what we see right away is that, oh, I have a repeat. So we need to look out now. We have to be cautious. There is a repeat in my domain. Remember, we're only looking for repeats in the domain, not the range. And when I come over to the range, my dependent variable, I can see here that the 15 corresponds to 24 and the 15 corresponds to 19. Well, once we come up with examples, you guys will see that this can't be a function. If we have 15, our input, it gives us 24, but we also have an input of 15 giving you 19. Well, that's giving you two different outputs for the same input. And you can't have two outputs for the same input if you're going to have the relation be a function. So therefore, this is not a function. And let's look at the definition. Why? This is not a function because an element in the domain, remember elements are each one of these numbers, is assigned to more than one element in the range. So the domain, these elements, they're the same, and it's assigned to more than one element in the range. So we have 24 and 19, both corresponding to 15, not a function. Okay, let's go over one more thing before you guys start on these problems. And I want to show you how the book creates these problems. And they're going to have a terminology that you will need to know in order to solve these questions. The questions are going to ask you if it's a function, and it's going to say some dependent variable is a function of the independent variable. So they'll ask a question, is x a function of y? Is h a function of p? They can use any symbol. And the general form is that we put is the dependent variable, remember that's the output, the dependent variable, is the output a function of the independent variable, the input. And this takes a bit of getting used to. It's wordy, but you guys will understand it after a while of working with it. So let's look at an example problem that comes from the book. If we look at this, now in this case, here's the question. We have a table. Now you can see that the table is written horizontally, no big deal. We have our x on top and our y on the bottom, and here's coordinates, or here's numbers that are associated with the domain and the range. Now the first question, it says, is y a function of x? Is y a function of x? Now remember, it's is the dependent variable a function of the independent variable? Is y a function of x? So therefore, y is the dependent and x is the independent. Now this is what we normally think of with x and y tables. X, horizontal axis, is normally associated with the independent. But the book is trying to teach you that it doesn't always have to be that way. Okay, so we look at the independents, and are there any repeats? 0, 1, 2, 3, 4, 5. There's no repeats for this one. No repeats. And so yes, this is a function. Because each one of the domain corresponds to a one-to-one correspondence with an output. Okay, now they've switched the question for B. Is x a function of y? So now you can see that they've switched it, so therefore y is the independent and x is the dependent. So we need to come up here and switch this. So now it's backwards. So now if we look in the domain is for the y's, and if we come through here, do we have any repeats? Well, yes, we do. And these repeats, well, it says that the input gives me 2 as my output, and the input of 4 gives me 3 as my output. Well, we can't have one input give us 2 different outputs. It doesn't make sense. So therefore, this is not a function. I'll just put not a function. Okay, I hope this clarifies, and we'll have more example problems posted on Edmodo.